Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou.
And I'm Mary. For math homework help, call in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Email dothemath@kern.org. We're online at dothemath.online.net and on social media.
All right, nicely done, Mary. So thank you very much for that. So where do you go to school and what grade are you in?
I go to Ronald Reagan and I'm in 6th grade.
So you're at the head of the line kind of now in elementary school, right?
Yes.
So have you been at Reagan for a long time?
Yes, since kindergarten.
Since kindergarten. So is there anything you think you're going to miss next year about Reagan? You've been there for 7 years now.
Yes, the chorus teacher is going to leave.
The what?
The chorus teacher.
But you're going to be in another course, right?
Yes,
But maybe that person will go to that school, maybe?
probably.
Oh, well, we'll see what happens, right?
Yeah.
All right. So did you know that this is the first show of season 24?
Really?
Season 24. This is the first show of season 24. You're almost 24 years old too, aren't you?
No,
You're about halfway there, aren't you?
Yes.
You're like 11, 12 years old?
Yes.
Are you 11 or 12?
I'm 11.
11. So you're just about halfway there, right?
Yes.
So you know what we want to do? We want to say a very big thank you to the Kern County Superintendent of Schools for hosting us and allow us to do this for 24 full seasons now. We've done it for almost 24 seasons, but we started kind of halfway in that first one. And we'd also like to welcome and thank Tuolumne County Superintendent of Schools for joining us this year and coming on board. So we anticipate a lot of students calling in from there, possibly go and check those guys out and do some activities with Tuolumne County students.
fun.
And yeah, it should be a lot of fun. It'll be fun all season long. And this is season 24. You are the first person on the show this year.
Yes.
How you feel? Pretty good?
Yeah.
There you go. That's the way to do it. Are you ready to help me do our social media problem of the day?
Yes.
All right, let's take a look at it together. So it's going to be up on the board here. So if you would read that for me, please.
Find the sum of these fractions, 1/3 and 3/12.
Okay. Now, usually when you see a math problem, there's some operations in between it, like add, subtract, multiply, or divide. There's no operation in there.
Yes.
So what do you think we have to do?
We have to look at the directions.
Okay, well, let's look at the directions again. What does it say?
Find the sum of these fractions.
Does that help us at all?
Yes,
How does it help us?
because it says find the sum, which means addition.
So find the sum. So what's the key word in there?
A sum.
Sum.
Yes.
Not like find some answer, but find the sum?
Yes.
Okay, so when you see the word sum, that tells you you have to add whatever it is they're talking about.
Yes.
So we're going to add 1/3 and 3/12. How would you like to go about this?
Finding the common denominator.
And what does that mean?
By seeing the LCM of 3 and 12, which is the least common multiple.
Okay, so 3 and 12. So if I'm finding the least number, isn't it 3?
Yes. No, it's not.
Well, then what is it?
It would be 12 because 12 is a multiple of 3, but it's the least one.
Okay, so that means 12 can go into 12 and 3 can go into 12.
Yes.
Okay, all right, so I've got that part straight. So now what do I do, though? I mean,
Now you have to match up the 3 and the 12 by multiplying 3 times 4 to get 12 for the denominator.
okay.
And you have to do the same for the numerator. So you would multiply 1 times 4 and you would get 4.
All right, so you added a couple of other terms in there, the denominator and numerator.
Yes.
And there's some students that may not know what we're talking about right now. So the denominator is the number on the bottom.
Yes.
So the numerator is the number
On the top.
on the top.
Yeah.
And we had to multiply the bottom, the denominator, by 4, so you said we had to do the same thing to the top.
Yes.
So the 1 would become,
A 4.
so 1/3 is the same as 4/12?
Yes.
You're sure?
Yes, I'm sure.
Okay. So now we have 4/12 and 3/12, and what do we do with that?
Now we have to add those together.
And what do we get, 7/24?
No.
I don't even see that as an answer.
No, 7/12. You only add the numerator, not the denominator.
Why? If we're adding the top, don't we do the same to the top and bottom, add them?
Well, we have to keep the denominator the same because it's the least common multiple. We're changing the LCM if we add them together.
Okay. So if I have 4/12 and you have 3/12, together we have 7/12.
Yeah.
We don't have 7/24.
Because you have 7 out of 12, not 7 out of 24.
Very good. I'm just glad that you were able to explain that, because there are some students that said, well, whatever you do to the top, you do to the bottom, so you added it across, so let's add across to the bottom, right?
And
Yeah.
Mary, can I ask you, thinking about that bottom number, what does that denominator mean? What does it mean? We know it's the bottom number, we know the name is denominator, but what does it really mean?
It means it's like so the numerator would be like out of 12 because 12 is the denominator. So it would be out of whatever the denominator is.
So you're telling me the numerator's a part and the bottom is your whole?
Yes.
Very good. So you're confident that it's 7/12.
Yes.
Can we simplify 7/12? Because there's a lot of times they say simplify things.
No, you cannot because 7 is a prime number.
And it's also your favorite number, isn't it?
Yes, it is.
We're going to get into that in just a little bit. But, you know, I mean, this has just happened to me where you saying it's 7/12. You're not saying it's 7/12 because 7 is your favorite number?
Yeah. No.
Well, okay, which is it?
Maybe.
Yes or no? Maybe.
No.
Oh, my, you got me all confused now.
No, it's 7/12.
All
I'm
right,
sure
let's
it's
take a look and
7/12.
see if indeed you are correct. There you go. Nicely done. Way to go. First problem out of the way.
Yes.
636-4357 is that phone number. We do have phone numbers available all the time, and you'll see them periodically at the bottom throughout the program. Time now for today's Math in the News. All right, well, for today's Math in the News, we are honored to have Dr. Tanya LaMar from Struggly with us. How are you today, Tanya?
Great, so excited to be here.
So I know that you are the CEO for Struggly, and before we get into exactly what Struggly is, when students hear struggle, a lot of times they have a negative kind of feeling with that word, but for you it's pretty much the opposite. So what is Struggly?
Yeah, so Struggly is a math program for students in kindergarten to 8th grade. We're considered a curriculum supplement. And we are integrating the research from Dr. Joe Bowler, who is a professor at Stanford University. And our content is all about challenging students to embrace struggle. So many of us get the idea that we're not math people if we struggle on something. But meanwhile, struggling is absolutely a part of the process of learning anything challenging, and especially math. So we're called Struggly because it's all about embracing the struggle and persisting through it, all while having some fun along the way. Our content is very visual and creative, and it's all about getting that deep conceptual understanding of math, which we know that's what it takes to learn math at the highest levels, is to really start to make sense of it at the conceptual level rather than just memorizing.
Yeah, well, everything you just said makes sense, because at the end of the last school year, I had my students try it for a couple of weeks, and they absolutely loved it. They wanted to know if they could do it at home, and I said, we're just going to do this in class. But that's how into it they were, and they didn't realize how much time they were spent doing math on the activities and the way they were created. One of the things, though, that throws the students off a little bit when they first start with Struggly is there are no instructions. So kind of explain that a little bit, why there are none, and the benefit of not having those.
Sure. Yeah, so there's two main reasons why we have no instructions. The first is we actually consulted with the lead experience designer. Her name is Celia Hodent, and she was the lead experience designer for the game Fortnite, which I'm sure a lot of students are familiar with that game. And what she helped us understand is this concept called intrinsic motivation. How do you design an experience or a game where the user wants to keep playing just for the sake of play, because they're so intrinsically motivated by what's happening in the game, they want to keep playing. And that's what we wanted to embed in Struggly. And part of that is having no instructions. So you're immediately in the driver's seat, figuring out how things work for yourself. And so the intrinsic motivation was part of it. The other part of it actually comes from research in the math education space. And that is around the importance of students expressing and exercising their own agency and authority when they're learning something in math. So instead of the teacher saying, this is the new math idea and this is where it fits in the stuff you've learned in the past, we know that for students to really be able to own the knowledge and apply it in all the spaces that they'll need to, it's more important that they are the ones discovering it for themselves, so that you're actually the one filing it away in your own brain because you've done the exploration, the understanding how it works, and you fully own that knowledge that you generated through your exploration. So those are the two main reasons of why no instruction. So for intrinsic motivation, and because we know that's what's best for math learning, for students to really own the knowledge that they've created. You also asked, what's the benefit of it? And that really comes from neuroscience research. So a lot of us think that being good at math is, people that are really good at memorizing and never get anything wrong, and that's what it takes. You have to just be a math person. But we've learned from neuroscience research that's not true. Everybody can be a math person. And what it really takes is when you learn a new mathematical idea, you want to be connecting it to other ideas that you've learned in the past, other representations, other ways of thinking that you've used in the past. And what you're doing is you're creating these brain connections. So when you have a mathematical idea that you've learned and you've explored it through multiple representations, you've actually built multiple brain pathways to that mathematical idea. And so when you're faced in new situations in school or outside of school where that content might apply, your brain has multiple pathways to go and access that information and apply it, because you yourself have created those pathways in your own brain. That's not something your teacher can do for you. Students need to be doing that on their own, because it's their own brain that they're building while they're doing it. So that would be the benefit for the no instructions, is it really puts the student in the position to build those brain pathways to be able to use their mathematics flexibly as they move on.
Well, I'm glad you covered a lot of that, because that was a lot of what I was going to ask you about, and the pathways and things like that. The intrinsic motivation, we certainly do see that. And on Do the Math, we like the students to struggle and kind of explain to us what they're thinking about as they approach different types of problems. And I know that when you were talking about the benefit of play just for play, because when students are confronted with something new, that's the first thing we want to do, is play with the things like manipulatives or a new idea, and how does it fit with them, so that they can better take ownership of it. So that was something that I was glad that you were able to touch on. So what do you do if somebody said, hey, you know what, this sounds great, we really want to try this? What does somebody do if they want to get Struggly?
Yeah, so we have the option to try Struggly out for free for at least 60 days. And that is available on our website. So if you just go to struggly.com, there is a free 60-day trial. You sign up, we send you your information, and you can get your students logged in right away and try us out in your classrooms.
All right, perfect. Dr. Tanya LaMar, thank you very much for being with us today on Do the Math. I know the kids love the struggle in class, and the kids on Do the Math, they always, like they're a little anxious because it's live TV, but they do benefit from that struggle. And at the end of it, every single show, they always ask if they can do more, because they love the struggle, and then they can see the benefit of it at the end. So Dr. Tanya LaMar, thank you very much for joining us today on today's Math in the News. We'll be back with more right after this. Our mathematician of the day, Benjamin Banneker. Benjamin was a tobacco farmer who achieved fame as a compiler of almanacs, and they relied on the sun to determine this time of day because they didn't have watches or clocks at their house. After looking at a pocket watch one time, he was able to get some different woods, and he was able to make and produce a working pocket watch. He loved all sorts of math puzzles. He couldn't get enough of them, and there are a lot of different puzzles that happen in everyday life. So one of them is, you've always got a drawer full of socks, and not all the time are they matched up all the time, so you have to figure out, all right, how many socks am I gonna have to pull out until I finally get a match? So there are 10 blue socks and 16 gray socks in your drawer. You reach into the dark, you can't see them, you have to take out how many socks until you get some that are gonna match. Well, if I pull out one,
it could be blue, right? The next one I pull out, it could be gray. Well, the next one you pull out has to be blue or it has to be gray, right? So at either point, it can either be blue or it can be gray, but at that point, you will have a match. So the minimum number of socks you will need to pull out of a drawer would be 3 socks. Just think rationally and reasonably about it, and you can just see, take one of each color out. If you get lucky, there could be 2, but you know you're gonna have to pull out 3 in order to make sure you have a match. Another one of the problems that a lot of students get confused on is doubling, but it depends upon where you double from. So the number of eggs in a basket doubles every minute. The basket is full in 1 hour. When was the basket half full? So the tendency is for some students to go, all right, after 1 minute, the number of eggs doubles. Well, if I started with 0 eggs and it doubles, there's nothing left in there, right? But they're saying that it was full in 1 hour. So let's just say we started with 1. So if we start with 1 egg and it doubles after a minute, we now are gonna have 2 eggs. You can keep going like that until you get to the hour, but that's not what the question is asking you, how many eggs are in the basket. It's asking, when was the basket half full? So after 1 hour, which is 60 minutes, it was full. Now it doubles every minute. So the minute before that, the 59th minute, it was half full. So the question is, when was the basket half full? At the 59th minute. So just thinking about it a little bit logically like that is an easier way to do it. Benjamin loved problems like that. Everyday situations, things that would be puzzlers for a lot of people. Benjamin loved them. That's our mathematician of the day.
Did you know that the division sign was first used by a Swiss mathematician? His name was Johann Rahn, and he used the symbol in 1659. Now you know.
Did you know that about the division symbol?
No, I didn't.
I didn't know it either until right then.
Yeah.
You learn something new every day, huh?
Yes.
Now, the thing before that, it was called Meet a Mathematician, one of our new features that we have this year during our 24th season of Do the Math. Have you ever met a mathematician?
No.
You haven't? You're a mathematician.
Well, I never knew that.
Yeah, you are a mathematician. You're an awesome mathematician. As a matter of fact, we're going to see just how awesome you are right now.
Okay.
I think one of the things I had mentioned at the beginning, because the answer to that social media problem was 7/12.
Yes.
And I think you chose 7/12 because 7 was your favorite number.
No, I didn't. I just said that.
Okay, we're going to let that go by. But anyway, so 7 is your favorite number.
Yes, it is.
Why is that?
Because it's like in the middle. It's not like a solid number. Cause like.
It's not a solid number?
Yeah. Well, that's what I call it. Cause like it either ends with a 0 or a 5. That's what I call solid numbers. Cause like it's like I don't know. It's like solid, but like
All right, it's
like
solid.
it's in the 7 is in the middle, and it's not too big.
Well, if I go 0 to 10, 7's not in the middle. Are we going 0 to 14?
5 to 10.
5 to 10?
Yeah.
Oh, so 0 to 5 are solid.
Yes. No, 0 and 5.
0 and 5 are solid.
Yeah.
But the numbers 5 to 10 aren't solid, but the one in the middle is solid.
No, 5 is solid, 10 is solid.
5 is solid, 10 is
If
solid.
it ends,
So friendly numbers.
if
It
it ends
sounds like
with
a friendly number.
if it ends with
Okay,
a 0
so
or a
would
5.
3 be solid?
Yes. No, I thought you were
What?
about the time 3, like 3 p.m. Like that's a solid.
So at 3 bells,
no.
when the bell tolls 3 o'clock p.m.,
Yeah.
the bell tolls 3, 1, 2,
Yeah,
3,
because-
3 bells,
Yeah, because the minute is 0, 0, not the hour.
and that makes it solid.
Yeah.
So you like
All right,
307.
I hope you're
Like
getting all of that with the solid numbers.
if class starts at 8:59, I don't like that. Why doesn't
Well, I
it start
certainly
at 9?
hope when you go to school later on, you don't get an 8:59 class, because I know you're not going to be there on time, so that's not solid.
Yes.
But anyway, we're going to talk about the number 7, hopefully a little more. You and Marylou, head on over to the board. We've got a little thing for you to do. So on the left-hand side, Mary, you see the numbers 2 through 12.
Yes.
Yes.
If you roll 2 dice, what's the lowest number you could possibly get?
2.
2, which is why it starts with 2.
Yes.
If you roll the same 2 dice, what's the largest number you could get?
12.
That's why the 12 is at the bottom, right? And you get everything in between, right? So what I'd like you to do is on where it says roll, underneath the dice,
Right there.
hit roll. And what is that total?
5.
All right, Marylou, put a tally up there for 5. All right, keep going. I'll let you know when to stop.
Okay.
So you just tell us what you keep getting.
9. 7.
Favorite number.
4.
There it is again.
7 again.
Okay, here's our 6th roll now.
8.
All right.
5.
Our 8th roll.
7 again. It knows it's my favorite number.
Yeah, it does.
4.
All right, so let's stop there. All right, so Marylou, how many times did we roll all together?
We did 4, 5. Was it 10?
So we rolled 10 times. Right, if we use the number 10, we can consider that
Solid.
10 out of 10 is 100%, right?
Yes.
Okay, so out of the rolls that you did, which one came up the most?
The 7.
The 7. I'm going to circle.
So the 7 came up the most. Do you have any idea why that would happen? Is it just because it's your favorite number, or can you think of another reason why that would come up most often?
Look at your chart.
Because this time it's actually in the middle between 2 and 12. The middle is 7.
So we have 1, 2, 3, 4. We have 5 there, and we have 1, 2, 3, 4, 5 there. So our mean,
Is 7.
is 7.
So if you're talking about the number in the middle, like you did with the 0 and the 5 and 10 and 7 solid, 7's in between 2 and 12, isn't it?
Yes.
That makes it solid,
No.
but it's your favorite number. Wouldn't it be a solid number?
Because it's a prime number.
Okay, because it's a prime number. But can we just agree that it's prime and it's solid?
In this case, it's solid.
In this case, it's solid.
Yes.
But there's a reason why.
Because it's the mean of 2 and 12.
Okay, but think about the different ways. How many different ways can you get the answer of 2?
There's 2 ways.
What would you have to roll to get a 2?
A 1 and a 1.
There's only one way to do that, isn't there?
Oh, yeah.
Okay, what about a 12?
There's like about,
What do we need to roll to get a 12?
oh, a 6 and a 6.
There's
can't
only
do-
one way to do
Oh,
that.
There's no
Yeah.
other combination.
Yeah.
How many ways can you make a 3?
1. There's only one way to do that.
Is there
'Cause-
one way? So,
Oh, well, I
A
mean,
1
it
and a 2.
depends. Oh, yeah, a 1 and a 2. Unless
But-
you get a 2 and a 1.
or a 2 and a 1.
But you had the same numbers, 1 and 2.
Okay.
Or 2 and 1.
Okay.
Yeah.
So let's say there's 2 ways to do it,
Yeah.
Okay.
okay? What about a 4?
There's 2 ways. You could get a 3 and a 1 or a 2 and a 2.
Okay, now, but you're saying there's 2 ways, but would there be more? Because think about it this way. A 1 and a 3 is the same as 3 and 1,
Yes.
which would be 2 ways.
Oh, yeah.
And then we add the 2 and 2.
So that'd be 3
Which is-
ways.
So you can think about it like that. Now, if you take the reverses, like 1 and 3 and 3 and 1, and you go, we're taking those out,
Yeah.
then it would be 2,
Yes.
right?
Yes.
Now, what about an 11? How many different ways can you get an 11?
Only 1 or 2.
5 and 6, 6 and 5, right?
Okay.
Now, think about 10.
3. Or no. Yeah, 3.
So why were you saying with
5
3?
and 5.
Yeah, 5 and 5.
Okay.
2 and, oh, wait. 6 and 4, and 4 and 6.
Okay.
Okay. Now, do you see the pattern that's going on?
Oh,
As you
it-
get
it
closer
is-
to the middle, you have more opportunities to get that number, right?
Yeah,
Which number do you think is going to have the most opportunities to come up?
7.
Probably because it's solid, isn't it?
Well, in this case, it's solid.
Okay, in this case, it's solid.
Yes.
So we'll agree that the 7 comes up most often, which is why a lot of people consider 7 to be their lucky number or their number. It's your number because it's a prime number, and in some instances, it's a solid number.
Yes.
All right, very nicely done. Hey, you know what? For doing some great work so far this afternoon, you've got yourself a ticket to the Kern County Fair, so congratulations on that. Hopefully you're able to go and have a little bit of fun. We'll be back with more right after this.
Hi, my name's Elisa, and welcome back to our series on Chapter 3 Number Sense for the California Math Framework Series. In this segment, we will focus on how students from grades 3 through 5 progress through an understanding of fractions. We encounter fractions every day. Could be through baking. It could be through splitting a cookie with your friends or a sandwich with your family. Fractions are more than just numbers. They're about an understanding of equal parts of a whole and building a foundation of mathematical thinking. We'll explore how students began their journey on fractions within the 3rd grade. Students are focusing on understanding, comparing, representing fractions as a part of everyday problem solving. Students will explore fractions by representing equal parts of a whole. They may start with unit fractions, like 1/3, 1/4, or 1/5, and how they fit on a number line. They can also look at equal parts of a fraction by filling in an area model. Joining me today is Luke, and Luke is going to help us look at a number line. So Luke, what do you notice about this number line?
It goes from 0 to 1 to 2.
It does go from 0 for 1 to 2. Do you notice some marks in between 0 and 1?
Yes.
Okay, what do you think those might be?
Fractions?
They might be fractions. How many different segments are there?
There is 5.
There is 5. So what we're going to do is we're going to count using 1/5. So would you say that this is 1/5?
Yes.
All right, you ready to count? We're going to say this first one, and we're going to fill this up until we get to 1. Are you ready?
Okay.
0 fifths. What comes next?
1/5.
Good.
2/5. 3/5. 4/5. 5/5.
Ooh, and what do you notice about 5/5 and 1?
It equals 1 whole.
Oh, how do you know that?
Because if I look above it, it says 1.
It does, you're right, it does. Do you want to keep counting with me?
Okay.
All right, let's keep going. What comes next?
6/5. 7/5. 8/5. 9/5. and 10/5.
Which is?
2 wholes.
2 wholes, that's awesome. So we're going to look at this number line to answer our next question. All right, Luke, let's say your sister Peyton is running a race, and she is 1/4 of the way through the race. Let's locate where 1 would be when she's done with the race. 1 whole would be on the number line, and you can use a pen to help you think that through.
About right here.
About right there? Okay, go ahead, draw the line there. And let's write. Awesome, 4/4. And that's where 1 will be? You drew some bumps here. Can you explain that to me?
Because if I used them, I would know where it would be if I did the same aim amount on each time. I would know where the 4th would be.
So you did the same amount each time. So this would be what?
2, 4.
You can write in.
2 fours. 3 fours.
I love it. That's great. Thank you, Luke. Elementary students develop a strong foundation in fractions through grades 3 through 5. In 3rd grade, students began with unit fractions, seeing them not only as equal parts of a whole, but also as numbers on a number line that can be compared and counted. In 4th grade, students build fluency with equivalent fractions and operations with like denominators. In the 5th grade, students expand to more complex operations, including addition and subtraction with unlike denominators and multiplying and dividing fractions. This progression builds fluency and flexibility and confidence over time. It's important for students to use representations to show their understanding of fractions. Using these models and representations helps students to see fractions in multiple perspectives, both building fluency and flexibility. So let's continue exploring problem-solving approaches while fostering flexibility and efficiency in our thinking. Thanks for tuning in, and keep doing the math.
A lot of work with fractions today. You dig fractions?
Yes.
They're kind of fun, right?
Yeah.
And sometimes you could work a fraction, and if we did 7 over 49, that would be 1 over what?
1 over 7.
That's a solid number, isn't it? It's a prime number. It's your favorite number, right?
Fine.
Anyway, I'm going to let you keep on going on that. 636-4357 is that phone number. We do have phone tutors available Tuesdays and Wednesdays between 3:30 and 5:30. And we would like to once again say thank you to Kern County Superintendent of Schools for welcoming us and helping us do our 24th season of Do the Math, and to welcome our friends at Tuolumne County Superintendent of Schools as well. So we look forward to doing a lot of work with those guys up a little bit north. Have you ever been to Sweet Fix?
No.
You have not? Yes. Well, I'm going to tell you right now that I met Tom and Kate about 1.5 years ago, and since then they have been friends of Do the Math, and if there's one thing they do well, it's make ice cream. Do you like ice cream?
Yes, I do.
Oh, yeah. Check this out. All right, we're in Bakersfield at Sweet Fix Creamery. We're with Tom, one of the owners, and you guys know how to make some ice cream, and some really nice ice cream. We're going to make the Do the Math blueberry pie today, right?
Right.
All right, let's go.
So we start with heavy cream. We want to do about 36% heavy cream. We're going to do some whole milk, and we also have some sugars and emulsifiers for that.
So the first part was 36, so is everything a third, or is it that's the base and then we go off of that?
Yeah, the whole milk brings that down to hopefully about a 16% butterfat ratio. That's what we're trying to get, and that's that creaminess and texture that you want.
All right, let's move on.
Yeah, great. So we're going to pour the base, split it so we can add the vanilla and egg yolks. Egg yolks also give it that creamy texture, is what we're going for. So we're going to do the vanilla first.
And how much vanilla goes in?
About a 1/3 cup. And that this will create 3 liners for us, which
Okay.
will do about 48 to 54 scoops in the store. Yeah.
So now the egg yolks.
Yep.
And this is strictly yolks, not the whole egg.
Exactly. Sugared
And
egg
why
yolks
is
again. Because they got to get the egg whites out, and the yellow really just helps it bind. The white actually creates problems, so the egg yolks create more, they call it the French style, like a custard style.
Okay, so you're separating that.
Yep,
All right.
exactly. So we're going to add these. Make sure we get all of it. Okay, that one. Now we're going to blend it, immersion blend it.
And is this
Get
a
ready.
recipe that you picked up from someplace, or you came up with this after trials and errors? And
Definitely trials, lots of trials. We have a batch kitchen at home. We
Okay.
make a lot of ice cream at home, so that's what we're doing.
All right. And how long do you blend it? Is it just kind of a sight thing, a feel?
Yeah, sight and feel. I'd say at least 30 seconds, maybe 60. Make sure that egg yolk gets in there, vanilla gets mixed in all the way. It's got to be perfect. You'll know. So now we'll add the rest of the base here. Make sure we got a full till. They'll be ready for the machine. So let's go. This only takes another 15, 20 seconds. They'll be fully blended. So you don't see the egg yolks anymore.
So this is the base for whatever type of ice cream you're making?
Pretty much.
Okay.
Yeah. If we added the vanilla and egg yolk, it creates that French vanilla base. If we don't do the egg yolk and vanilla, it's our sweet cream base. So we do our base for either of them.
Okay.
Yeah. So it creates that. So now it's ready for the machine. So we can take this over and drop it in.
All right. All right, well, we made the mixture. It's now churning away, and we need a specific flavor. We're going to make blueberry pie, P-I, blueberry pie ice cream for Do the Math. We've got a blueberry pie from Murray Family Farms. We love it. You usually don't get it like this, but
No.
we've cut it up a little bit.
Right.
And this is what's going to go into the mixture.
Right, so the mixture is going to come out. We're going to start lining it, is what we call it, so it can be for presentation. So we're going to put it in here, and you're just going to mix it in and get it ready for final.
Okay, so we're lining it. We've got 3 liners, and how much is each one of these contain?
Well, this will do about 16 scoops, so I would say that maybe 18 scoops, so about
Okay.
72 ounces.
And we have 1 pie to satisfy all 3 of these.
Yes, it'll do all 3. Perfect.
Oh, good. Well, I'm looking forward to it. We're ready to go?
About to happen.
All right.
So we're going to take it from here. The mixture came out. It's all ready. It's ready to be layered. So I'm going to dump it in here, and you're going to take some of the pie and then blend it in with that. Our perfect vanilla base.
All right, so we got the base going in, and we're filling it about 1/3 of the way.
Yep. Well, about you're about 1/9 of that. 'Cause you're going to layer it, do it more and more.
All right.
Just kind of fill up the top. That's probably good.
Spread it
Go ahead
out.
and mix all that in.
All right.
Fold it. gonna
How's
turn
this
it
looking,
over.
Tom?
Looks pretty
I
good.
ready to come work for Sweet
Yeah,
Fix
I think
here?
you're ready to retire.
Retire? I'll still be
next-
working. But this is fun
Well, I
work
thought
too,
you were
you
gonna
know?
volunteer. Oh, got it.
Oh, all right. Dude, I'll tell you, that pie was looking beautiful, but it looks even better now, mixed in here. So how far are we, Tom, from the end now?
Pretty close. So now we're just trying to finish it. We got the mixing done. Now we're just going to try to decorate and finish it, do the art piece of this.
Oh, so now we smooth it out a little bit, make it nice for the presentation?
Yep.
All right.
Go ahead and kind of do that, and I'll show you the last part. We got some blueberry jam on the side. So we're going to kind of
Oh, here we go now.
just get mixed in here. And I'll show you how we finish the decoration of this. Gonna mix it in. Get the nice swirl
Oh,
going.
there we go.
It's got to present.
Right, and it's getting a little deeper down in there with
Yep.
that syrup, right?
Yep, sure is. And then we clean the sides up, and this will be ready for tasting.
So a blueberry pie ice cream with the blueberry pie courtesy of Murray Family Farms and Sweet Fix Creamery making this up for Do the Math as we kick off our 24th season. Dude, I gotta tell you, this looks beautiful.
Yeah.
Do I really have to wait for it to freeze a little
Nope,
bit?
let's eat it right now. Let's get some. So let's see what you think. Got to dig down in there and try to get a pie piece though as well.
Oh, all right. That's the goal.
Yep,
Oh, I think I felt a little bit right there.
probably did.
Hey, you know what? That can't be too big, can it?
No. Let's see, can Mike do that?
Oh,
A little left. What do you think?
dude, that is awesome.
Good.
Thank
That's
you very
awesome.
much.
You got it.
Tom, Sweet Fix Creamery, we dig it. It's the 24th season of Do the Math, and we got blueberry pie. Come on down to Sweet Fix and try yours. That is good.
Perfect.
We have to use these little spoons all the time?
Actually, when astronauts do experiments on the International Space Station, for instance, to look at the effect of the space environment on organisms, that environment is actually technically called microgravity. That is, things feel weightless, but we're still under the influence of Earth's gravity. Now, the very microgravity that we're trying to study up there can make experiments actually really kind of difficult for a bunch of different reasons. First of all, stuff floats. So losing things in the ISS is a very real possibility. For example, there was a set of tomatoes that was harvested in 2022, put in a bag, and it floated away, and we couldn't find it for 8 months. So to prevent this kind of thing from happening, we use a lot of different methods, such as using enclosed experiment spaces like glove boxes and glove bags. We use a lot of Velcro to stick stuff to. Another issue is bubbles in liquids. So on Earth, bubbles float up. In space, they don't float up. They'll interfere with optical measurements or stop up your microfluidics. So space experiment equipment often includes contraptions for stopping or blocking or trapping bubbles. A third issue is convection. So on Earth, gravity drives a process of gas mixing called convection, and that helps circulate air. But without that, in microgravity, we worry about some of our experimental organisms and whether they're going to get the fresh air that they need. So we might do things like adding a fan to their habitat, or if we can't, we'll take their habitat and put it somewhere where there might already be a fan on ISS, or in a corridor where we think there are going to be a lot of astronauts moving around and circulating the air. Yet another issue is the fact that a lot of the laboratory instruments we use on Earth are not designed for microgravity. So to ensure that gravity doesn't play a factor in how they work, we might do experiments on the ground where we turn them on their side, or upside down, or rotate them on a rotisserie to make sure that they keep working. So as you can tell, for every experiment that we do on the International Space Station, there's a whole team of scientists on the ground that has spent years developing the experiment design. And so I guess the answer to how we do research in microgravity is with a lot of practice and preparation.
Science is just fun, isn't it?
Yes.
And space also, right?
Yeah.
And I think you learned a lot about space in 5th grade last year, right?
Yes, and gates.
Would you go into space if you had the opportunity?
Yeah.
You
but
would?
I would kind of feel scared though, because bad things might happen.
Well, but once again, it's kind of like you were getting a little nervous before the show, right? But it's kind of anxious. You're not sure what's going to happen, but you feel pretty good about it, right?
Yeah.
You just want everything to go well, and everything has been going well, right?
Yes.
Good. we've been doing a lot of fraction work, and we've seen a lot of stuff with fractions today. You like fractions?
Yes.
You ready to do some?
Sure.
How about if I give you some fraction work, but I don't tell you any directions?
Okay.
That's the beautiful part
We'll
about
see.
Struggly, and we're going to be doing Struggly quite a few times throughout the season on season 24 of Do the Math. So this is Divvy Up with Fractions, courtesy of Struggly. So you two ladies head on over there. And Mary, I would like you to kind of explain to Marylou, what do you think you have to do here? Because it says 6 divided by 2, and you've got 2 yellow shaded in and 6 others. So what do you think you need to do?
Probably like divide the 6 squares into the 2 squares.
It's up to you and Marylou. Go ahead.
Yeah.
So what do you think this is equivalent to? First of all, let's look at 6 divided by 2. What do we know about 6 divided by 2?
It equals 3.
It equals 3. Okay, so knowing that, what do you think this then represents?
What one group would probably be?
Okay, so then how many groups do you think we need of those?
3.
Okay, so now we have to figure out,
How are you going to put 3 in there somewhere?
how are we going to put 3 in there?
So maybe hit the question mark? I don't know. I mean, probably be hitting
we
things
could hit-
because we have
do
to
you-
try things
go
to
for
have it
it.
work.
What do you think?
Oh, they gave us numbers.
Okay, so do you want to try to put in what we said?
Then use the check mark, I think.
You use the check mark.
Oh.
And up in the right, it says very good.
So did we get it right?
Yes.
Yes, we did.
All right, so hit the level, I believe, down at the bottom.
Okay, hit this right here.
So
Okay.
we're going to see how far you can go, Mary.
Okay.
So you can go as quick as you want.
All right.
Okay.
Go for it. And hit the check. What do you think that this is dropping? What is this representing?
I think it represents like how many would be in each group,
Okay.
and this would be the amount of groups, but they put it in different colors so I could see how many groups there are.
You could see the total 6 groups?
Yes.
Okay. All right. Let's go to level 2. Ooh. What do you think that means?
6 divided by 2 over 2, which equals 1.
Okay.
So
Let's see. Did we get it? Yay! Nice
All right, you're on level 3.
All right.
Let's see how far you can
There
go.
we go.
Let's try to
Keep
get
going.
to 7. At least that's solid.
Ooh. Now we have 6 divided by a half.
well, when we divide it, we have to do keep, change, flip. So we would keep the 6, and then we would change this to the opposite, which is multiplication. So it'd be 6 times, and then this, we have to flip it. So it'd be 2 over 1,
Can
which equals
we
2.
write? Can we write on this at all? Is there's
No, you're just going to put your answer
Okay,
in there. And
all
go.
right.
Well, so now we know it's 6 times 2 over 1, which is 2.
Okay.
And 6 times 2 is 12.
Okay.
So let's see if 12 is.
Let's see.
All right, Mary, you've got.
So again, we know that each piece represents a half.
yeah.
And how many halves do we totally have?
12.
We have 12 halves, right?
You've got about 2 minutes
Okay.
to get 3 more levels.
Let's go.
Okay.
Let's go. So here, how many total pieces do we have?
Well, we have, oh, right there we have 3 pieces.
Right? Okay. So again, you're saying you want to use your same strategy as you did? Okay.
Yes. 4.
How did you get 4? Go ahead and put it in if you
So
think
you
it is.
flip it over and like, so you flip it over and then you do 6 times 2, which is 12, and then 12 over 3 is 4.
Okay. And it's showing us we have the 4 groups, right?
Yes.
There you go. Next level.
So it kind of did it like there was a
Yeah.
remainder and it dumped it into
Dumped
the next
into the next one.
Yeah.
So now this little piece is 1/6. And so how many total is this broken into?
It's broken into 6 pieces, but we only have one of the 6.
So what do you think that's going to be?
36.
Okay.
Oh, that's going to take a long time.
It's going to,
Yeah, as that's going, let me just remind you that if you got about a half a minute, maybe a minute, and you're coming up on level 7,
go. go, go. Let's see if they'll
So
let
you
us.
have to complete level say. You can't get ahead of the game there, sister. You can't do it
taking
faster than the
forever.
technology.
It's taking
Patience,
long.
young lady.
But again,
patience.
we know if one piece, and if this is 6.
All right,
so
now you can hit it.
we have the groups, right?
All
we
right,
have
you
6.
got to level 7.
Okay,
24.
24. Go for it.
That was pretty quick. So
Yeah.
explain to Marylou how you got
Yes.
24 so quick.
I did the same thing, keep, change, flip. I kept the 6, changed that to multiplication, and flipped that, so 6 times 4 equals 24.
But we also know that if this is broken into 4, right?
Yes.
That's what that one shaded piece means.
Yeah.
This is broken into 4, right? And then I'm going to have 6 groups of that. And we
Yeah.
know 6 groups of 4
Is 24.
is 24.
So Mary, that's your first opportunity using Struggly.
Yes.
There were no directions. You guys just kind of had to figure out what was going on, but you figured it out. You got up to 7 levels, up to number 8. Did you like struggling with that?
Yeah.
So
I wasn't really struggling. It was kind of easy.
But as you keep going, we could get you up to like level 20, and then guess what?
I'd probably start struggling.
You're probably going to start struggling a little bit, right?
Yeah.
So at the beginning, right, everything's smooth and everything's cool, right? Not as good as solid numbers, I'm sure, prime numbers, but everything is going well.
Yes.
You good with that?
Yeah.
Good. Well, I'm glad you had fun with the Struggly right there. We'll be back with more right after this.
A meteor is a small particle, typically of dust, that is crashing into our atmosphere and burning up at very high altitude. And there's a lot of dust and larger particles, grains of sand and pebbles, that are in the solar system. And they're from leftover debris from the formation of the solar system, they're from asteroids that have crashed together, and they're from comets that are spewing this material. The Perseids are what's known as a meteor shower. That debris that we're encountering is caused by material that's coming off of a comet that is orbiting the sun. Randomly, the Earth encounters this dust to the level of tens of thousands of tons per year, and that material burns up in the atmosphere, and some of them we see as meteors. The orbit of the comet is very narrow, and so it's only a very short time period of the year that the Earth encounters this. But at that time, and in this case, in the middle of August, we see an increased number of meteors that all appear to come from one particular location on the sky. The reason why we have the name, the Perseids, the zenith appears to be coming from the constellation Perseus, a Greek mythological figure and one of our constellations. The Perseid meteor shower is particularly noted because at peak, it's been recorded that there have been hundreds of meteors per hour, and that's quite a spectacular show. You're getting multiple meteors per minute, and then the large number of fireballs. Fireballs are slightly larger material coming from the comet in this case, maybe up to the size of a grapefruit, a soccer ball size chunk of material, and that again encounters Earth's atmosphere and burns up. There's more material to burn up as it's going through the atmosphere, and so we see both a brighter object and we see the burning trail last longer because there's more material there. We're not under attack. Very few, if any, meteors make it to the ground. These small dust particles and even particles that are sand grain size or even small pebbles almost certainly burn up 100% in the atmosphere. And they're burning up at very high altitudes, 50, 60 miles above the Earth. Understanding what a meteor is, that it's a particle from the solar system that's been, orbiting the sun for eons and is unfortunate enough to crash into the Earth and burn up, gives us a little bit of pleasure of something that's neat, right? But I think more fundamentally, as an astrophysicist, I think that anything that makes people look up and feel connected to the universe is vital and important. And even more so if going out and seeing this spectacular natural phenomenon causes someone to become interested in astronomy and science. I think that's what it's all about, and so I think that's the importance of these sorts of events.
In studio, we have Mary, a 6th grade student from Reagan Elementary. It's pretty cool so far, isn't it?
Yeah.
Yeah, so you've had some fun doing the different math activities and stuff like that?
Yes.
All right, good. You ready for one more?
Sure.
All right, over to the board.
All right, let's go.
So the number 1 that is in that figure right now has to stay. That number cannot move.
Okay.
All of the other numbers in the blue circles can move, and you can rearrange them however you like. So let's try this. Solve the puzzle.
So
Have
what
any
do
idea
you
what you have to do yet?
Huh?
Do you have any idea what you have to do?
Yeah.
What do you think we need to do?
I feel like we have to like number like the steps of like how we're gonna trace it up and like one like without going over the same line.
Okay, without going over the same line?
That's a good idea.
So what do you want me to move where?
Well, before you do
This is
that,
one.
Yeah.
that's a good idea.
Okay.
Yeah.
But we're not going to do a network today.
Oh.
So is this, can I ask, does it have to do with adding
Yes.
equivalent sums?
So it's called line of 3. So if you start the 1 and go up, and then go up one more, that's a line of 3.
So they all have to, has to,
Those 3 have to equal if you go from the 1 across,
There.
if you go across the middle, and if you go from the farthest right up. All of those
okay.
lines of 3 must equal the same number.
Oh.
so they all have to equal.
Go to it.
So what are you thinking? Because we know that this all has to equal. Do you want to tackle the bottom? Do you want to tackle a side, the middle? Where would you like to start?
We could go up that way.
Up this way? Okay.
So we could do 1. So we have the
We have
1 right
one,
there. I think we could try to do maybe 3.
A 3? Okay. And then you want me to put that there?
Yes.
Okay. So if that's at 4, okay.
Yeah. So it would be 1 and 3 would be 4, and then whatever's here is the final answer.
Right.
Okay.
So remember that this one by itself is going to affect the side as well.
Yes.
So before you do something like that, you know that 1 and 3 already make 4.
Yes.
Right.
Is there any way to make those other 2 on the right side,
Side
equal
4.
4?
Oh, no.
Okay. So do you want
Yeah,
to move that?
move that back,
Okay.
yeah.
So remember, whatever we put here, it's going to have to be the same sum here. Think about the rolling of the dice,
Yes.
right? Think about that, how we played with those numbers.
Yeah.
So if we can't make another sum of 4,
Yeah.
but is there something else we could put another number in here? Say like if we put 5
5.
here,
Yeah.
can we make 5 over here?
Make a 5 over here.
Yeah, what 2 numbers will,
Well,
I'm
it
sorry,
needs to equal
6.
6.
Yeah, I was
Right.
like,
6.
yeah. Yeah, 2 and 4.
Okay. 2 and 4, okay,
And then those 2 would equal both of like
right,
these
they
2
both equal.
6. And then would these 2 have to also be the same?
Well, remember that this line and this line has to add the same.
Yeah.
So,
Oh. So if these 2,
right, if we put,
Well, right now the
A
bottom row
3.
equals 5.
yeah, that
And the
equals
middle
5.
row equals 7.
That equals 5, that equals 7, but they have to equal the same. So I'm just going to throw a number in there. If we put 3 here, we now have
10.
10. Can we put a number in here to make this 10?
Yes, a 6.
Ah, 6.
All right, let's
And
try our addition.
therefore-
Whoa,
Oh.
hold on there. What's 1, 6, and 4?
1,
6.
10.
Oh, wait.
Oh,
wait.
that's 11.
That's 11.
Oh yeah. I was thinking 4 and 6
Yeah.
is 10. Okay.
Let's get the 3 out of there.
Yeah, we'll move that.
I know that throws me off with that.
Yeah.
Okay.
So we have 7 and 4 and 5. Sorry.
Do we want to change it up something different?
Okay.
Because there's, even if we put 7 in, instead of 6, if we put, that's even going to make it higher, huh?
Yeah.
But if we put 7 there, what do we have?
14.
And we still have 11 there, right?
Yeah,
So do we need to switch up maybe our numbers here?
Yeah. I
Okay.
feel like if we switch these 2, we might get somewhere closer.
Okay, let's switch those, see what happens. So now we have 9 and 3.
Yeah.
I'm going to help you guys out.
Okay.
Put the 6 at the top.
Boom.
Put the 7 in the very bottom.
Right here?
Yep.
Oh,
Okay.
wow.
Okay. Now, get rid of the 2, the 4, and the 5.
And let's rearrange. Okay.
Okay. Now, on the left-hand
We have
side,
8.
you're going to have everything equal 11. All of the lines are going to equal 11.
So what do we need
No.
to equal 11? Not 5, but
Four,
So
yeah.
that equals 11. So we
Yes.
know this side has to equal 11 as well. So what numbers can I put over there to make it equal 11?
We could put 6 and 3.
We already have 6.
Oh yeah, well 3 and then 2 because
Okay.
yeah,
And then here,
that would be 5.
we put 5. So let's see, what's the bottom equal?
10.
10.
Oh,
Ooh,
that's 12.
that's 12.
Yeah.
Just flip the 2 and the 3, I think.
Yep. Flip those 2.
Now try it.
Oh
Now-
yeah.
Now we
11.
have 11,
11.
and we have 11. And it doesn't matter with the 6, because this equals, we have that as 5, we have this
Yeah.
as 5, right?
Yeah.
So those also equal 11.
All right,
So much
nicely
fun.
done. Come on
Yeah.
over. It took a little while, and I wanted you to struggle a little bit with it.
Yeah.
But check it out. We've got some blueberry pie ice cream, courtesy of our friends at Sweet Fix, and the blueberry pie from Murray Family Farms. You ready to try some?
Sure.
You want to try this? Good. Here we go. Let's eat this up.
Cheers. Oh, I'm excited. Oh, yum.
This is good.
That
This
is some
is-
good stuff right there. Did you get any of the actual crust or anything yet in there? Do you?
Oh,
Nope,
no,
not
but I
yet.
have a piece right here.
Uh-huh.
That's
You
a
got to
big
get that in there right there.
It's a big piece.
Well,
This is excellent.
this is going to be, there you go.
Yay.
It's good.
Ooh, that crust was a little bit frozen right there.
Yeah,
It's
well,
hard to
yeah.
bite into right there, right?
Yeah.
So
But
good.
anyway, Sweet Fix. Every month they've got an assortment of flavors that come out. And this month they've got blueberry pie going on right there. So they've got a bunch of other flavors. And they also have an assortment of other flavors that are also out all the time. So if you like some other flavors, they have them all the time. But every month they have about 4 to 6 different flavors, I think. So
Wow.
every month you can go and check out the new stuff.
Wow.
So you're going to go to Sweet Fix and check out some more blueberry pie ice cream?
Probably.
Yeah.
And all you have to do is go in there and go, hey, I heard you guys have this thing called blueberry pie ice cream. And go, I was the one on the show when that was introduced.
Really?
And I bet you they give you an extra scoop or something like that,
Yeah.
right?
I'll
That's not a
see.
bad deal.
Yeah.
So did you learn a little something today?
Yes, the
Good.
line of 3.
Yeah, there you go, right? You learn something new every day, right? Did you
Yeah.
have fun today?
Yes. I
That's
did.
the most important thing right there. Did you know that you are now an ambassador for Do the Math?
No, but now I know.
Do you know what that means?
Like, I know what it means, but like I don't know how to explain. Like it means like part of something.
You are part of the Do the Math family now, and forever and ever you are part of the family. Do you know what you have to do as an ambassador for Do the Math?
Tell people about it.
That's exactly it. See, that's why I knew you would make an awesome ambassador, right?
Yes.
You've already got your uniform on, so you can tell people about Do the Math, because I'm sure when people see that, they're going to go, hey, Mary, what's up with the Do the Math? And you go, are you kidding me? You didn't see me on the show? Right? So you
Yeah.
can tell them all about it, right?
Yes.
All right, good deal. And you also get this exclusive Do the Math Rubik's Cube.
That's very nice.
Do you know how to do a Rubik's Cube?
I only know one thing to do with it, but I'm not the best about with it.
Okay, well, you know what? I know how to mix it up, but I don't know how to solve it.
Well, I don't know how to solve it either. Oh, I wonder how I could solve
All
this.
right. So good. I'm glad you had fun. Hey, you know what? It's only the beginning of season 24. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union. with additional production assistance provided by these supporters of education.